Let's do all of this stuff. Okay, sharing screen. There we go. And let me, well, we already saw the movie. So today is, in fact, again, our last class. Okay, our last class of the semester. We are done with this ESS2 after that. And to end up the class today, we are talking about global warming. We keep on the same topic as Tuesday. And at that time, we saw last time the observation of climate change. Well, first, the difference between climate and weather, what's driving climate. Then we talked about climate change and how we know about climate change by looking at all the different tools to have an idea of the climate in the past. And we've noted that this climate has changed in the past through different proxies, such as high score, for example. Let's see if I do have, yes, I do. And today, we in fact talking more specifically about global warming, which is what's happening now. So instead of looking at the past and how the climate has changed in the past, today we're looking at what's going on now. And we are talking about now and the future. And we will talk about tactics, about mitigation, about adaptation, and also very briefly about geoengineering, stuff that we are doing on the planet to help having less impact regarding the global warming, and especially the greenhouse gases emission. Okay, so let me just check up. There is no. Okay, I've seen a question about test. It's all coming at the end of the class. Okay, so I'm coming with extra information at the end of the class. But to not lose our focus, I'll just come and talk about global warming. Okay, so let's talk about what is global warming and mostly the consequences of global warming we have seen in the very last slides of the last lecture, that our concentration of greenhouse gases has never been so high over the past million years, that our temperature is globally increasing. This is definitely something that we can observe. And prediction showed that, I mean, different projection done by computer shown that definitely there is an increase of the temperature on the planet. But as you can see, the temperature on the planet is not equally warming up at the same pace everywhere. There are some places that definitely will warm up faster than other ones. For example, where would be the main increase of temperature being observed? Easy question. Just look at the map. Okay, North Pole, definitely. Why is North Pole? I mean, we could say, okay, the poles, but if you compare North Pole with the Antarctic continent, the South Pole, you see that the South Pole is not as impacted as the North Pole. What can be the main difference explaining that the North Pole definitely will see a huge increase in temperature versus the South Pole? It's not because of the tilt of the Earth. That has happened since millions and millions of years. The tilt just make a season. So, when it's spring and summertime, we receive more sunlight in the northern hemisphere, but during winter time and fall, the southern hemisphere is the one receiving most of the sunlight. So this is just something shared being every year. So what could be a reason why the North Pole is more impacted? Think about what you may have heard about the North Pole, the news happening over there. What is kind of a recurrent, very common topic to come out of the media regarding the North Pole? So Dylan, you have starting a good point. That's definitely ice. In the south, you have land, but not already, yes. So going with Kiana, ice melting, the greenhouse gas says it's something that is being emitted everywhere, I would say. No, the North Pole receives less direct sunlight than other parts. And polar bears do not play a role in global warming, okay? You may find some kind of research being done of cows, for example, on cattle, and global warming, the fact that the farts from the cattle can contribute to global warming, but I haven't heard about the farts of polar bears and global warming, to be honest. So the greenhouse gas get trapped when ice melt? No, it's in fact a little bit more not directly linked to greenhouse gas. So what happened is you have in the North Pole, you usually have these kind of ice sheets, okay? So you have the sea ice as, who was saying it? Sorry, trying to go back to, that was Dylan, I think, who said that, that the North Pole was just on the sea, okay? So what happened is normally you have the sunlight, okay? And what happened with the sunlight when it's reaching up the sea ice? Well, the sunlight got reflected back to space. So that means that there is a less, at that time with sea ice, there is less warming happening, okay? This is our case with sea ice. But let's imagine that, sorry, I do not have so much space. I took a lot of space just with my drawing. Let's imagine that you are melting this sea ice because of global warming, okay? This is because of global warming. You're warming up the temperature, and so the sea ice start melting. And so instead, now you have the ocean, and I'm sorry, I'm a bit limited in where I can draw right now. Now my sunlight is still right here, my light, okay? What happened to the sunlight? It is not reflected back. The sunlight is directly being absorbed by the sea, absorbed by the planet. And what happened is you're increasing, you're warming it up more, okay? Because there is no more reflection of the ice. So the difference, I mean, the North Pole is mostly sea ice. One of the differences, there is less ice in the North Pole than in South Pole. Then the ice in the North Pole is mostly covering the sea, which tend to melt faster than the ice covering the land on the Antarctic side. So this, because you will, by warming up the temperature about the same at both places, you will provide about the same heat at both places, but you will melt much more ice in the Northern Hemisphere, meaning that mostly the ice will disappear and you will just increase, that's what we call a positive feedback, when by melting, by warming up the place, you melting the sea ice and you making the warming even worse. In the Antarctic, the melting will happen, but it will be slower because it's not under the sea, because the ice is huge. And so there is still a lot of reflection happening, kind of protecting this huge melting to happen, but it's not the case in the North Pole. Okay, let's see if, okay. So that's definitely one thing we observe. North Pole will definitely be impacted a lot. Then after, another consequence is precipitation. And we might think, oh, it will be warmer, so that means that more evaporation will happen. More evaporation means more rain for everyone. It's not true. More rain at some specific zones. Mostly, oh man, this is messy. And I've done a lot of drawing. Unfortunately, I should be more careful in the next time cleaning up my stuff. Let's see, it's coming, guys. Almost done. All right, yeah, finally. So the main increase of precipitation is at the equator. Do we have a lot of land in the equator? Not that much. So most of the ocean will take most of the extra rain that will be produced. Also in the temperate zone, okay, all of the Northern Europe will receive a little bit more rain, but the other regions, such as California, we will receive, in fact, even less. So we can expect to have more drought happening in places. So definitely increase in temperature generally, but some places will increase more than temperature than others, such as North Pole. Precipitation, it's depends on the place you are. Equator and northern latitude will receive more rain, but mid-range latitude tropics will definitely receive less, and we definitely will suffer of drought. And so in terms of consequences of this global warming, this is only a few examples of what can happen. As it said, you have some drought happening longer here in the US, in California. Definitely we are in this type of case. Other places will receive heavier precipitation because of more evaporation happening. With the Arctic ice melting, the sea level is rising up. There is another thing also that is right now more important than the melting of the ice contributing to the sea level rising, It's what we call the thermal expansion of the ocean. The ocean has been taken about 90% of all the heat we've had because of global warming. With this 90% being taken in the ocean, in fact, water molecules are taking more space. So the ocean just naturally expands its volume because it's getting warmer. And this definitely leads to the most significant sea level rising we've been observing. And then, of course, glaciers will be melting. With the two left in Yosemite are mostly gone at this point. And it's just, unfortunately, history repeating. So all of those are definitely impact we know that will happen. And then after, this is a global consequences based on some degrees of difference. But definitely, the number of degrees by which we are warming up our atmosphere and our planet by the end of the century, or even after anyway, is definitely a major issue. And so right now, with this Paris Agreement and the last treaty, climate convention being signed by most of the countries, we are trying to limit our temperature between 1.5 to possibly more 2 degrees Celsius. This is definitely, I would think, most likely where we are gonna be. And you can see the different effect of the temperature. With an increase of 2 degrees Celsius, for example, the sea level globally, will rise by about 56 centimeters, which is about 2 feet, mostly. So 2 feet of increase of sea level, which some places will be seeing more, okay? If you increase by 3 degrees, you're getting to 7 meters, about 7 yards. And 4 degrees, 9 meters, about 9 yards, okay? Just to give you an estimate. There is also, of course, impact on the water. By 2 degrees increase, we'll definitely have water shortage. Then by 3 degrees, most of the glacier will disappear. Half of the Himalayas glaciers will have been lost. And then at 4 degrees, forget about glaciers, and mostly we're dealing with a lot of drought. We see also issues regarding the food access. For example, at 2 degrees, which is what we expect, hopefully to get in some way for the less worse impact, if I can say, we'll definitely see impact on the agriculture activity with crops and soil getting to desertification. And so we will be losing some of the crops. Then after you see 3 degrees Celsius, we'll see a lot of fish being depleted, not only by fisheries, but also because of the increase of temperature. And then, of course, 4 degrees, it's becoming unbearable for a lot of countries. And finally, from some aspect of the biodiversity, with 2 degrees, all the coral reefs we know will have disappeared off the planet, that's for sure. 3 degrees, the marine biodiversity will have taken a big knock on that one. That's in fact linking with what we see. And with 4 degrees, it's even on land that a lot of biodiversity will be suffering. So those are, unfortunately, I mean, these 4 degrees is part of the possibility of the change in temperature by the end of the century. That's why they're citing this 4 degrees Celsius. We are aiming right now, and we're crossing fingers that we can limit the increase of temperature to 2 degrees Celsius, but this is not sure. Okay. So keep taking about this change in temperature. Why such a change? I mean, why just a little change in temperature can be so drastically different? Well, it's just the fact that by moving a little bit the temperature of the world by 1 degree of half a degree Celsius, what happened is you're making a shift into the extreme event that you were observing before. This is our normal scenario right here, where we have kind of a pretty average temperature right here. That would be the world average temperature. And this, what we observe right here and what we observe right there, are the extreme events linked to very cold temperature and extreme event being related to very warm temperature. If we move by just half a degree, 1 degree, this curve, that means that you're moving the temperature by half a degree or 1 degree, you are moving away the extreme event on the outside. So of course, you may be not having any more event or like extreme event linked to cold because you're moving your graph from the cold, the planet becoming warmer, so you don't deal with cold conditions anymore, but you're increasing the primes linked to hot weather, which might not be easy and easy to deal with. So by making this small shift in average, you make a big change in the extreme. And those big changes will have consequences such as crop failure, increasing the amount of wildfire we're observing here in California, but not only in California, severe more drought being observed in California, but not only, some intense rainfall. For example, California, we will have less rainy days, for example, in the future, but when there will be a storm, we will receive more water at this point. So usually we will deal with more flash flooding. That can be a big issue. And hurricanes, it is said that the frequency of the hurricanes may not change too much, but the intensity, how strong those hurricanes can be, this will definitely be bigger. So that definitely can change. What we observe is that those temperatures will definitely be bigger on land because we know that the sea, the water takes more time to absorb the heat. So the land will definitely warm up faster, which by consequence mean that the northern hemisphere will increase its temperature faster because we have 2/3 of the lands in northern hemisphere. We saw that the major temperature will be observed in the Arctic, in the North Pole. And again, most of the extreme event will be linked now to warm to hot conditions in itself. And we have observed just in a matter of 40 years, more or less, since 1970s in the US, the number of extreme events have more than doubled over those 40 years. So it definitely showed that our increase of temperature is directly causing those extreme events to happen, which are drought, floods, hurricane, tornadoes. All of these things that sometimes make good pictures, such as, for example, hurricanes and tornadoes, but you don't want to deal with them that's definitely a major impact. So quick question at this point to you, based on what we've just talked, just to see if you are paying attention. Let's start the polling asking you, which of the following is not a change that has been observed on the planet over the past 100 years? Read carefully. All right, 15 more seconds. 5 seconds left. And so we're missing 9 people. You'll have a second chance for the polling right after. So sharing results, you all at 64% agree that in fact we haven't observed the increase of ice sheets or glacier thickness over the 100 years that has passed, okay? In fact, the ocean pH has decreased. It means that it's being more acidic, and there is definitely an acidification of the pH, okay? So first question, let's go for the next question now, asking you, it's just normally a review question of what I just mentioned to you, which of the region of the planet is warming up the most? Should be an easy one. right, so we're missing a couple more. So I'm giving 20 more seconds to ending up. Okay, so let's close the poll. 70%, so still a few of you didn't maybe pay enough attention, but 70% of you are correct. It's polar region. In fact, I should be even more careful saying the northern polar region, where we observe the main increase of temperature. Okay, so let's stop sharing just to not bug you with that. So in terms of changes we have been observing at this point, we definitely have observed, oops, let's see, sorry, I thought I had removed that slide. Let me see if I didn't, right here. So let me move to the next slide, this one. We have been seeing example of already a glacier disappearing mostly, or at least reducing drastically. So at this point, for example, I show you pictures of a glacier national park in Montana, where you see a glacier a century ago that was full of ice at that time. And this is, of course, at the same time of the year, okay? You have to make those type of comparison on the same month, for example. So that's supposed to be, to be honest, I forgot the month, but based on the condition and kind of vegetation and look, it probably more like a spring condition or summer condition. But you see the huge difference. At this point, you just have some traces of the glacier. And the glacier in Yosemite look kind of very much the same. They are almost gone. There are just traces of a past glacier being there. The problem is, you may know that, like, for example, California really use a lot of water resources from those glaciers. And the snow, I mean, all of this is melting usually starting in March, April, but we have normally snow melt up to June at best, sometimes July. And this is providing a consequent amount of fresh water to California. But not only, we have about 2 billion people who are directly using glaciers as a resource for fresh water. So what will happen when those glaciers will disappear? How those more than 2 billion people will be able to get access to water? So that's kind of a big issue. What we've been observing is also the change in the population of trees we observe with elevation. With this figure, it showed that those trees is usually the typical distribution of trees with elevation that we observe, which is in fact, the trees do not decide about the elevation. They decide about the amount of humidity, the precipitation, the temperature that they have access to. But that means that if this is becoming too warm, well, the trees will try by just pollinating, but they will have a tendency to move to higher elevation. And we've been observing that happening. One of the examples that tend to be referred a lot is usually the coffee bean tree, where that we've observed that the population go higher and higher in elevation, little by little. Another observation, wildfires. We've been observing that there is definitely an increasing of wildfire in the Western US, and also that the season of wildfire is happening over a longer period of time during each year. And you see that over about 30 years of data, we almost double our amount of wildfire being recorded for the Western US. Also, as mentioned, the season initially, I mean, a couple of decades ago, we were on a wildfire season for about 5 months. Now it's estimated that we have a wildfire risk kind of spread over a possible 7 months of season. So definitely the number of wildfires has increased and the seasonality also has increased. All of this definitely happening because of global warming. What happened in California? We have less precipitation, meaning that your soil getting drier. All the vegetation get drier. The surface, I mean, which is usually made of leaves and organic material that is under decomposition, all of this is very dry. You just need a little spark that can be natural or that can be sometimes unfortunately caused by humans to make this just going into flames so quickly. And so this is definitely a reason why we observe most of these wildfires happening at this point, because of global warming, and of course, I should say also because of human population. And unfortunately, projections show that definitely we are going to see more and more wildfires. If we look at the state of California, definitely we're observing increasing between 0 to 200% more or less, but some region of the Western US will even be worse than that, because we are warming places, higher elevation places that had not really experienced so much wildfires in the past, but now we are drying up this vegetation. It's a huge amount of vegetation that can burn. So it has a big, great potential for wildfire at this point, meaning explaining why we observe those high elevation regions to possibly be at risk for wildfires in the future. Okay. All right, so good news. See, the future is bright. Lots of wildfires, drought, losing the glaciers, and but there is still, good thing. We'll see that there is way to adapt first. There is way to at least reduce the potential effect. And after, we have to remember that we are in some way, that's true, I think I forgot to mention that there is a say that a lot of people say that we are destroying the planet. And I think I used to say that. We are not destroying the planet in itself. The planet will not be destroyed by us, okay? We are not, we don't have the Death Star in space and just using a laser beam and destroying the planet. It's not what's happening. We are definitely modifying the planet. We're probably one of the only species on this planet. I'm saying probably one of the species because it has happened in the past, but we are one of the recent species on the planet who definitely have a huge impact directly on the planet. And so we are modifying the planet. The planet will still survive, definitely. Biodiversity will get hurt. Vegetation and animals definitely will, we will lose a lot of them. But as any extinction, we can expect maybe kind of some way a rebirth of that at some point. The difficulty is that everything happens so extremely fast, we don't know how big the hit will be at this point. But still, we are modifying the planet, meaning that the planet will survive it. How we're going to survive it as a society is another different story. We don't know about that. And I was saying we cannot say that we are the only species on the planet who have changed it. Okay, we have to remember the story of the Earth. One of the first species, or I should say, organism who has impacted on the planet were all of those cells who were producing photosynthesis and who has released oxygen into the atmosphere. Remember that at the beginning, the Earth's atmosphere didn't have any oxygen. And so we've been releasing this oxygen. They have been releasing, changing definitely the composition of the oxygen to 20%, adding 20% of oxygen. So they have modified the planet. And with all of that, dinosaurs, mammals, other type of families of organisms have, evolved on the planet. So definitely, it's not that we are creating a dead planet. There will be something after for sure. But are we part of this thing? We don't know. So how can we make sure to possibly be the century of a change? It's always say that we have to start doing a change. We have to do the change. Change is happening, but maybe at a slow rate. How can we possibly make the change? Well, I would say it's the easiest thing to say, but that's you, okay? You, in fact, I should say you and me, all of us together, we are part of this society. We are part of the prem. We can make changes. And believe me or not, you already have done. You've been learning from this class. And just also, finally, as I was working on this, I'm showing you a little bit of what you did very recently for those who did participate.
What about sunrise? What about rain? What about all things that you said we were to gain? What about killing fears? Is there a time? What about all things that you said were yours and mine? What have we done to the world? Look what we've done. What about all the peace that you pledged your only son? What about flowering fields? Is there a time? What about all the dreams that you said was yours and mine? Did you ever stop to notice all the children dead from war? Did you ever stop to notice this crying earth as we make sure? I used to dream, I used to glance beyond the stars. Now I don't know where we are, although I know we're drifting far. What about yesterday? What about us? What about this evening? What about us? Rather not falling down. What about us? I can't even feel. What about us? What about everything? What about us? I ain't even knew. What about us? What about nature's work? It's up in this world. What about us? What about animals? What about it? Your kingdom to death. What about us? What about elephants? What about us? Having lost their trust. What about us? What about crying well? What about us? Ravaging the seas. What about us? What about more than hell? Breaking what I believe.
All right, so see, you've done some changes. Okay, I'm sorry. In fact, some of the pictures were not maybe well rotated. Some of you, sometimes I had several pictures. I thought so much over the past that you find a way to make a slideshow. It's interesting. Years ago, you could definitely find those easily, and now I couldn't find any application. So I really focused on having the video done, and I didn't pay attention if the photos were correct or not up to now watching it with you. I wanted to have the chance to also discover it at the same time as you. So I will upload this video also online. Okay, you can have access to it, and definitely wanted to show that you know how to do the change, and also as in some way to share my experience with you. It's the first time I'm doing that with my classes, and I've done that with my 3 courses. And it's interesting to see that you've been the one, I mean, and not lying, you've been the one definitely took the assignment as it was supposed to be, really doing something for the planet. I've seen for the other classes, sometimes you look at the picture, it's like how this is helping the planet. You couldn't really understand the relationship between the selfie and what they were really doing that was good for the planet. But in your case, definitely, I see that you were planning what you learned. So we definitely need you. We need people also who are kind of inspiring us. And at this point, I'm sure, if it's not the case, you will know about Greta Thunberg in just a little bit. but we need people, and not just all people. We don't need only politicians. We don't need like a super rock star to make, and maybe a movie, Hollywood star to make those change or call for action. But we need just also regular people to suddenly come into the front stage and say, hey, let's move, let's do stuff. And this is kind of the example I wanted to show. So with this young girl, Greta Thunberg, that a lot of people may criticize, but also, I mean, she has been doing something more than anyone else over the recent years. She has been able, as a young woman, to inspire the new generation to do some changes. So let's quickly check the movie if it wants to play. Yeah.
My name is Greta Thunberg. I'm 16 years old. I come from Sweden, and I want you to panic. I don't want your hope. I want you to feel the fear I feel every day. And then I want you to act. I want you to act as if the house was on fire, because it is. Deforestation of our great forests, toxic air pollution, loss of insects and wildlife. These are all disastrous trends being accelerated by a way of life that we, here in our financially fortunate part of the world, see as our right to simply carry on.
We should not be the ones who are fighting for the future, and yet here we are. We will rise to the challenge. We will hold those who are the most responsible for this crisis accountable, and we will make the world leaders act.
You have stolen my dreams and my childhood with your empty words. We are in the beginning of a mass extinction, and all you can talk about is money and fairy tales of eternal economic growth. How dare you!
What I'm telling you to do now is to act, because no one is too small to make a difference. See you on the streets.
Okay, I'm sorry, I'm just reading Elizabeth's comment about the Fantastic Four and a type of teleportation system. The concept of, okay, interesting. Yeah, well, that's this idea of trying to find an escape room to possibly, instead of facing the fire, trying just to escape. Yeah, and then a lot of people can criticize also that we are spending a lot of billions of dollars in Mars and other exploration systems or technology, but it's also, I mean, at some point you start also to accept, because it's providing also some technology into the world and also for the benefit of the planet. So it's not just only always escaping the room. So going back into the context of this, with, I mean, people like you, people like Greta Thunberg, which is doing at a bigger scale at this point, she's in fact kind of going into a point, a very important point, which is in fact a communication gap. There is a strong communication gap between what our scientific community knows and has been proven already, and what the people think the scientists know. If we look, I mean, we have 97% of the scientists that, at least 97%, agree that climate change, I should say global warming, is a fact that is happening now. 97%. Okay. On this, that is exactly what happened, the number we know for the scientific community. If you ask anyone on the street, you will come with about 50% of the people telling you, some of them will tell you, oh yes, scientists agree on global warming, and you will have the other 50% about saying that, oh no, it's not yet sure. Scientists are still debating. I mean, at 97%, you are not debating anymore. This is already a fact. Of course, science never goes to 100%. But interestingly, the public, through possibly the media, what they're learning, their understanding of the situation, they think that it's still a debate happening, which in fact, kind of make things very even slower as a population to make changes to happen. If we look, I mean, people are thinking, you have exactly, this is a source from The Guardian, this is a source for CBS. You see that 55% on this one, this is a 52% about saying that you have, so that's why I'm rounding up to 50%, okay? So depending on the source, you will find between 45 to 55% in itself. So there is a discrepancy between that. Then after, there is the idea of not accepting it. And why don't we accepting? Because first we will find excuses, or we will in some way think that we are not aware, we don't understand carefully. And this is maybe a little bit more for my class of weather. I decided to exactly do the same lecture this week with my weather class, not because I was lazy, but was definitely a way also to conclude the class for ESS2 and ESS 15. But weather is definitely taking a good excuse to explain climate change. 33% of people consider weather to be climate. And we had the president that was before was making exactly the same mistake. I had in the past tweets from the government, and unfortunately also interviews showing that there was a mistake, a confusion between climate and weather. It's not because we have a cold week that it's not that global warming doesn't happen. Again, climate is seen over periods of decades happening. Weather is just a period of hours, days, maybe weeks, but no more. And so there is this huge misunderstanding or confusion saying, oh, it's becoming cold, so how can it be global warming? It's not because it's global warming that you will be in sweatsuit every day, especially in winter time. So, and if you take weather plus the fact that people saying, oh, naturally it's normal, temperature just change every day, change during the season, well, you round it up to 50% of the people finding the excuse just based on weather. So weather is really like a big issue. I mean, there is a lot of confusion again. And that's why I asked you at the beginning of class on Tuesday if you could make the difference between weather and climate, because 50% of regular people do not make the difference and take one for the other. And it's not the same. Then after you find the other reason, the fact that we go back into people thinking that we don't have enough scientific foundation for global warming, the news report, and et cetera, et cetera. But 50% again on that. Then comes also the misconception of climate change and global warming. I explained you last time that climate change is something totally natural that happened based on tectonic plates, volcanic activity, change in the orbits of the Earth around the sun, and changes in seasonal changing in CO2 or greenhouse gases, let's say. Those four drive naturally the climate change. Right now, the global warming we are facing goes over the explanation of natural processes. We have seen that not the tectonic plates, not the volcanic activity, and neither the orbits of the Earth can explain why we have such suddenly an increase of temperature. The greenhouse gases is not following any more normal or natural trend because humans have been emitting more greenhouse gases over the last 200 years. So when you see this kind of result where you have about 40% that telling you that they attribute global warming because of human and nature, it's still a way to escape reality and to excuse our action. Because in itself, you're still accusing nature to be responsible, of course. Of course, it's natural processes. We are based surrounded by natural reaction all around. But this global warming is mainly at this point driven by the emission as a society we are doing on the planet. So definitely, this should be the number of human activity shown to be the biggest one. Scientists have agreed that definitely to say that global warming is caused because of human activity. And how do we know, or what kind of communities, scientists are really working on that? Well, the scientists, just to be fair and square, they have decided to create an institution, an organization that is called IPCC, stands for Intergovernmental Panel on Climate Change. These IPCCs are the IPCC is a group made of hundreds or in fact thousands of scientists scientists working in different places over the world. They are not working for the same institution. They are not working for the same lab. They are not paid by any lobby to make their research. They are independent scientists. So at this point, the scientists could say, oh, humans are responsible for global warming or humans are not responsible for global warming. It will not change their salary. It will not change their payday. So they are not sponsored by anyone. They are just doing their research. And when they are doing their research after they're publishing, and they have all the community of scientists looking at their publication, that's what we call peer review, just to make sure that we are not saying stupid things or that we are not promoting things because there is a sponsor behind us. And every about 6-7 years, they are making a report just to express or maybe to illustrate, well, not illustrate, to summarize the art of research about global warming, the last news, the last updates, the last results, and the last forecast for the next coming years. So the first one was released in 1990, then comes 2001, 2005, 2007, 2014, and the sixth assessment report is scheduled to be released in 2022. So this is a major group working on investigating the impact, of global warming and really understanding the cause of it and how trying to propose some alternative to possibly reduce its impact. Then we have the United Nations, who created a framework convention on climate change, so a specific group working on climate change. They created this during the International Treaty of Rio in 1992. The goal of this convention of climate change was to make sure that during some important worldwide meetings from the United Nations, some rules will be taken some regulation will be taken and signed by the countries towards reduction of greenhouse gases emission. And this has been kind of settled down by the meeting following in Kyoto with the Kyoto Protocol in 1997 that has defined that there will be, starting from now, any new regulation of greenhouse gases being emitted by the United Nations will be supervised and will be checked by this organization. And since they're making annual meetings, what we call the conferences of the parties, the COP, just to quickly make a checkup of how each country have been doing every year. And the last one, in some way the most significant one, has been in 2015, the COP21 that happened in Paris. It's also called the Paris Agreement, that was signed, but mostly all the countries, I think only 3 didn't, not signed, but 3 didn't accept it. The US at this point with President Obama was going to sign it. We had a change in leadership with President Trump, who decided to resign and so get away. But good news, the US are back since this year. So it's pretty pleasant to finally talk about the Paris Agreement to you guys and say, well, the US is not the exception. In the past, I had a few slides explaining what would happen with the US being outside of it, but it's not the case. This Paris Agreement is really trying to lead the world to not have an increase of more than 2 degrees Celsius. And we saw why that's really an important case. Now, at this point, you know the difference between 2 degrees and maybe 3 degrees. It's dramatic, in fact. It's trying to help protecting the forests, which are definitely a sink for carbon dioxide, making sure to help the countries developing their more renewable energy, trying to not pollute too much, and going towards what we call a net zero carbon emission by the next second part of the century. And we'll come into that in just a little bit regarding this net zero emission. So a lot of countries have signed it up, close to 187, and that implies a lot of change regarding industry, regarding transportation, regarding, in fact, our emission of greenhouse gases, with a huge challenge of reducing our greenhouse gases. And I have this short movie to explain you exactly how this works. Oops, again, come on. Let's see, it should load, yes.
What is the Paris Agreement? The Paris Agreement is a legally binding international treaty on climate change to limit global warming to well below 2, preferably to 1.5 degrees Celsius compared to pre-industrial levels. This requires economic and social transformation to face the climate challenges now and moving into the future based on the best available science. The Paris Agreement works on a 5-year cycle of increasingly ambitious climate action. By 2020, countries communicate their plans known as nationally determined contributions. Countries communicate actions they will take to reduce their greenhouse gas emissions in order to reach the goals of the Paris Agreement. Countries also communicate actions they will take to build resilience to adapt to the impacts of rising temperatures. This may include information on adaptation and finance flows. The Paris Agreement also provides a framework for financial, technical, and capacity building support to those countries who need it. Starting in 2024, countries report transparently on actions taken. Collective progress under the Paris Agreement will be assessed through a global stocktake. This will lead to recommendations for countries to set more ambitious plans in the next round.
So this is definitely the two major institutions, one looking at the evolution of global warming, the other one trying to implement regulations and policies to decrease as much as possible the consequence, to decrease in some way our emission of greenhouse gases and the consequences coming with that. So in fact, we have three possible responses as a society that can be happening regarding global warming. So two of those responses are more like traditional ways. We can first adapt. So adapting is just, okay, it will be warmer, we will have less water. We have to start adapting our lifestyle to be used to be warm and to have less access to water. Okay, change are inevitable. Let's try to adapt. And definitely there will be a part of where we have to adapt. Then there is mitigation, which is let's try to reduce our impact, our emissions. So reducing, it would be here, reducing in some way our production of greenhouse gases. And there is a new type of method that is not really new, but thanks to technology, we can consider it more new than the other two ones. It's geoengineering, using science and engineering to possibly directly impact on the global warming by in some way modifying a little bit our planet. This is a little bit more tricky and dangerous. I'll have one slide about that. So how to do that? Well, with this class, we have been kind of overviewing all the issues, all the sources of global warming. We know that our energy needs to be more efficient. We have to have an energy that is not only relying on fossil fuel and have more renewable energy resources. Transportation, we have also to not use so much fossil fuel and have maybe more electric cars, with electricity, again, being done through renewable energy. We talked about building. Buildings are emitting a lot of greenhouse gases, CO2, during the construction site, but for the running of the building, in fact, because indirectly they use a lot of electricity using coals in general. Then we have reforesting. We are deforesting more than we are planting trees, even though, I mean, we never planted trees as much as nowadays. We have to be careful about our soil. We saw that we are desertifying too much and we are losing those soils, and those soils are indirectly contributing to global warming because there is no vegetation. They're absorbing more the heat, and so it's not good neither. And we've seen that operation purchasing in some way, when we talk about product, the creation of product has also an impact on global warming because manufacturing emits a lot of CO2, shipping emits a lot of CO2, and the waste we're producing produce greenhouse gases. And I had a quick movie also explaining what can be done and where it can be done.
People should care about climate change because it affects every aspect of the world that we live in. Climate change, according to science, is making the world a place that suffers more extreme weather events. So we're getting more storms in more places. We're getting greater droughts at the same time in more places. It's going to affect a lot of those things that we don't necessarily associate with climate change. And so it's going to have an impact on practically every person that lives on the planet. And with 9 billion people on the planet by 2050, all competing for resources, we need a better plan how to distribute those resources and how to make the things that we all depend on. people want to understand what they can do compared to, building a new coal-fired power station in China. Taking the bus as opposed to taking the train or flying doesn't seem to be making much difference. But actually, all these actions do add up and they do make a difference. And we've seen remarkable changes in Europe in the last number of years, partly because of laws, but partly because of greater awareness. We've seen emissions in lots of countries come down at the same time as people continue to enjoy good lifestyles. So it's possible to do it. It's possible to do it relatively painlessly, and it does make a difference.
So in terms of a country, how can we, we talked already on in terms of individuals, all the different changes that we can make. For the countries in itself, in terms of mitigation, two main steps can be done, the offset part and the cap and trade one, both in some way reaching to the same objective, which is carbon neutrality, meaning that by your activity and what you can, the pro and cons, you are reaching at the end an equilibrium where you didn't, your emission and production, your emission and absorption of CO2 are totally neutral. With the offset, I wanted this to be presented first. This is the offset part. The offset work with the idea that you are emitting by some of your action, you're emitting some CO2. Well, what you will do is after you did your emission, you will either do some action yourself or you will pay an agency to do it for you, for example, to plant some trees. And with the idea that by planting your trees, those trees will absorb the CO2 that you did emit with your first action. So you're trying in some way to make it back after you've done something wrong in some way for the planet. So all the carbon you're putting into from your activity into the atmosphere, you're trying to find a counter action to remove this carbon. So it can be an individual action, which tend to be free, free or at least low cost, but it tend to be limited. We don't have so many options. Or you can try to make a payment to a company. So for example, if you're an industry or you're a city, you will probably pay some thousands of millions of dollars for this company to make something that will be helping to absorb some of the CO2 from the atmosphere. The other one is a cap and trade, and this is a market that tend to be in evolution and kind of growing quite a lot because of course it's making money. The idea that all of the industries have a specific cap of pollution, and some of the industry like this one will not pollute too much because maybe they have already a good manufacturing system that do not pollute, or maybe because of what they're doing, they do not naturally pollute too much. Other ones are polluting quite a lot, maybe because they are burning coal to produce electricity. What happens is this company that pollutes a lot will give money to the other one to get access to some of its right to pollute. Because if you're looking at right here, you have the limitation of, what you should be, the limitation of what you should be polluting is represented with this bubble, but this company just use half of it. So if this industry who's polluting a lot, give some money to the other one, it can have the half leftovers to be polluting. It's just playing on numbers. And it's like, oh, I'm buying you 5 tons of CO2 that you are not emitting, and I'm giving you $5,000. I don't know about the price. But so it's just a trade of permits to pollute. Okay, each company, each industry have a specific amount of pollution. And if it's not reached, you can sell it to another company and make some profit from that. And so it doesn't work as an offset. It definitely has more money into this. This is part of the mitigation. In terms of geoengineering, which is the other way, they have figured out a few, this is only a few examples of what can be done. One of the most common idea is to do what we call carbon sequestration. So mostly pumping carbon from the atmosphere and have those pumps sending the carbons into the ground and just have the carbon being fixed in the ground. That's kind of course, the prime is by doing this, you are using pumps, you are using generators that may use electricity. And if this electricity is not made of renewable energy, you're polluting on the side. This can be an issue. There is this idea of sending some sulfur aerosols in the stratosphere. It's like the volcanoes. We saw that volcanic activity, when it happened, it tended to cool down the atmosphere because of the sulfur aerosols going into the stratosphere. So that will cool down the atmosphere, but it will only work for about a year or so. So it's very limited in the time, and you will have to do it quite a lot and huge amount of sulfur aerosols to be sent. So not really practical. Then we can do iron particles in the ocean. Why? Because the iron is a nutrient, very important nutrient for the algae, the phytoplanktons, to grow. And so if you're feeding those phytoplanktons, you're creating algae, meaning that they will absorb most of the CO2 to produce oxygen. But the problem is, this also work punctually, and then they might have some consequence of pollution due to algae. Not a good thing. Cloud seeding, the idea that you're sending into the sky some particles, some aerosols of silver. Silver is known to be a pretty good component to create clouds where the water will condense on it. The problem is clouds can have double effect in terms of global warming. Not half, but parts of the clouds may reduce the temperature, but part of the clouds can also increase the temperature. So at this point, not everything seems to really be kind of a solution. And playing honestly with the planet, playing with the systems, the natural system, it tends to be very dangerous. If, I don't know, I will just take one Hollywood movie that comes to my mind right now, and they even made a TV shows from it. It's Snowpiercer, where, the story goes beyond that, but it starts with the idea that scientists have thrown some kind of component into the atmosphere to cool down a little bit the temperature, but the system just made a loop or feedback on itself, and the cooling went to an extreme point that in fact no one could survive the cold. So that's kind of the idea. So you're playing with the system and it can be dangerous. So definitely I would say it's good ideas, but it shouldn't be the way we should go. At the end, we should be at least active very carefully. This graph show you from today to hundreds to thousands of years, the idea of us stopping our emissions. So imagine that we are reaching our CO2 emissions, our greenhouse emission within the next 100 years. That will be the peak. And then after that, we've been able, maybe because of renewable energy and other technology, we are able to reduce almost to nothing our carbon emission. That goes this way. So within about 200 years, more or less, if you look, we would be done with greenhouse gases, or at least we will see less of that. Well, it will take time for the greenhouse gases to stabilize in the atmosphere, okay? And then even after that, the purple line, you'll see that the greenhouse gases emission doesn't, the concentration in the atmosphere, it doesn't decrease, it stays the same. So even though we have stopped producing in the atmosphere, we're still staying with a lot of greenhouse gases into the atmosphere, which has for a consequence a temperature that will keep increasing very drastically over the first couple of 100 years, but after you kind of slightly increasing little by little, and without speaking about thermal sea level rising due to melting, and as I was mentioning before, the thermal expansion, just the fact that you're warming up the ocean. So the idea right now is, even if we're able to make the change now, and we are able to finally be more environmentally friendly and kind of try to reduce the amount of global warming, the effect of the global warming will happen for the next 100 years for sure. So it will definitely impact the future generation at this point. There is no doubt about it. Okay, and that's kind of the main point I wanted to finish with. But to not just finish with, to not end the class with only negative side, final words at this point regarding the class. First, one last extra credit survey. I will release it tomorrow, so that's the last chance to make some extra point. I think normally I have muted all the extra credit right now, so it is not confusing for you. But I will, of course, unmute them next week when all the grading will be done. So I'll let you know, I will make an announcement for next week, for tomorrow, about this extra credit regarding for the survey. Then, good news, let's go for it. No more quiz. At the end, I didn't tell you because I wanted you to pay attention to class, but there won't be a quiz on Monday, okay? This climate change was for free, if I can say. So no quiz on climate, no quiz Monday, okay? Because I was also realizing you will be in finals, and so just focus on your final at this point. No more quiz, in fact, no more other assignments due, okay? So the very last one will be the extra credit, but there is no more assignment beside that. And so with that, you are done with ESS2. We are not done yet with you. We still have to do some grading, but it's coming, okay? I'm pushing all the TAs and even myself, because I also have to do some grading regarding your participation, but all of this is coming. Congratulations. I hope you will enjoy a good summer or summer break. It depends if you're taking class. I'm instructing to class, so I'm not having too much break, but it's fine. Make honor of what you learn this semester. Okay, and I'm not saying this like really conventional, and I'm really thinking about it. Make honor to what you learn, because with what you learn, you are starting acting good for the planet, and you can even act better and better. Okay, so do your actions, tell the other ones around you about what they can do, and it will just make life for everyone better. Okay, and I cannot provide you a date, but definitely I will see you on campus for fall. I'm crossing fingers at least. And well, I'm sorry if I don't recognize you in case on campus, but feel free to stop me, okay? Because with the Zoom, I had some of your pictures, but it was not the same as seeing you in class. So with that, we are done with the class of today. We are done with ESS2. If you have any question, please feel free to use Teams. As usual, Teams definitely the best way. Emails, I'm very behind. All right. I wish you all a good luck with your finals, maybe a good break, and I'll see you soon around. Bye, everyone.
Thank you, Professor Masculine. I'll see you around.
Bye, Matthew.
Thank you. Thank you.
Thank you.
Thank you.
Thanks, everyone.
Bye.
Thank you.
Thank you.
Thank you, Professor. Have a good one.
Bye-bye. All right, Julian, I see you have a few questions. Let's see if, do you want to ask your question now, or let's?
Yeah, it doesn't necessarily relate to the course, but I know you're from France. I'm going there to visit my family in summer. I was just curious, completely off topic, any places in Paris you recommend visiting?
Paris. There are so many places. Bye, guys. I'm saying bye to the other ones in the meantime. Well, of course, you don't want to meet the Eiffel Tower, which is one of the main ones. There might be lines. I don't know how it is with tourists at this point, because I think they are just opening back now. They were on lockdown up to recently. You know what? Just for me to be sure I provide you a correct answer, write to me on Teams, and I will be able on, making a quick list of a few things maybe that definitely are good to see. Okay? Because
Okay.
right here like this, I'm not having the thoughts coming in. So
I'm sorry.
But no, you're fine. It's a good question, no problem. It's just I want to provide you a good answer, and I think I will have a better answer if I can think about it and quickly look at a map and my memories, place back all my memories into organizing it.
Okay. Thank you,
Okay.
Professor.
No problem. Have a good day too. Bye. Any other question? No. All right. I'll close the session then. Bye, everyone.